All right, we have one final example where we have this set of equations, and we start with the augmented matrix. 0, 1, minus 4, 8, 2, minus 3, 2, 1, and 5, minus 8, 7, 1. All right, well, I'd like a 1 in the top left corner, but I have a 0 here, so my first step is to switch the first and second rows around. So I get 2, minus 3, 2, 1, 0, 1, minus 4, 8, 5, minus 8, 7, 1. And this has the advantage that I already have a 1 in this middle position here. All right, but I still don't have a 1 in the top left corner, which I want to have here. So although I don't like fractions, I will divide the first row by 2. So I get 1 minus 3 over 2, 1 1/2, and the rest of the rows simply stay the same. 5 minus 8, 7, 1. All right, now I will subtract the first row 5 times from the third, and this so we get a 0 there. So my aim was to have a 1 in the top left corner, and now I want to create zeros here. The second row is already done, but I subtract to get a 0 here, I subtract the first row 5 times from the third. So the first row doesn't change, 1 1/2. The second row doesn't change, 8. I get 5 minus 5 is equal to 0. Minus 8 minus 5 times minus 3 over 2. So that is minus 8 plus 15 over 2, which is 7.5. We end up with minus 1/2. 7 minus 5 is equal to 2, and 1 minus 2.5 is minus 3 over 2. We already have our 1 here, so that's taken care of. I'd like a 0 here, so what I do is I add a half, I add a half times the second row to the third row to get a 0 here. Okay, so here we go. The first row doesn't change. The second row doesn't change. I get a 0. I had already 0 there. Minus a half plus a half is equal to 0. 2 plus minus 2 is equal to 0. And 3 over 2, minus 3 over 2 plus 4, so minus 1.5 plus 4 is equal to 5 over 2, or 2.5. And I never write fractions like this, because then calculating, using fractions like this becomes very difficult to calculate and is error prone. Well, now basically the solution has presented itself, because the last row represents 0 times x plus 0 times y plus 0 times z is equal to 5 over 2. And that means that this system is inconsistent. And it has no solutions. So when you encounter a row of zeros with the last element not being 0, you know that the system is inconsistent and you have no solutions. So these were the 3 examples of the 3 different types of solutions, and how you recognize them, and of course how you get to them.